Okay, so if you recall last class, we also discussed about the collection, Java collection and collections, okay. And collections is a class, and collection is an interface. And basically, we discussed Java collections is a hierarchy. So under it, we also discussed some interface, is it like a list interface? Okay, and under list and some other interface we also discussed. We also discussed like array list and linked list. And we also discussed there are some interface like queue, is it, and the DAG. So the hierarchy. Okay, so list implement both list and the queue, is it? So that's regarding the collection, and the collections is a class. So it has a number of static method. And those static methods can do some general work, such as like sorting, finding maximum or minimum, and the search. So, so that's just the general idea about Java collection and collections. Okay, and today we will learn a new data structure called PriorityQueue. So within the word, it also has the word queue. Is it previously we learned the queue? Queue itself is first in, first out. Is it? But here we have the priority. Okay, so then it's not strictly first in, first out. Okay, so priority queue, then the idea is generally, so with the object that you are going to put into the queue. So here is a queue, is it? So you also have priority, is it? So higher priority first, is it? So priority first. After priority, then, so if priority is tied, then you follow first in, first out. Otherwise, it's based on priority. Okay, so whoever has a higher priority, then when you add, you are not add at the back. You will, the highest priority will be added at the beginning. Okay, so that's called priority queue. Okay, otherwise it's just a follow first in, first out. So this is called a priority queue, and priority queue is a concrete class. Okay, it's concrete. So it has some of the operations features from the queue, but it adds priority. So that's why priority queue it also implement, if you see, the queue interface. Okay, but not list. So basically priority queue. So it implements the queue interface. So that's the general idea about priority queue, okay? And then let's see the priority queue idea, general idea, okay? So it's an unbounded priority queue, okay? So it's based on priority heap, okay? So the order, generally, it's going to be ordered by natural ordering. And if you recall, last class, we also discussed for the comparison. We discussed two interfaces, comparable interface and a comparator interface. Is it for comparable interface? So a class implement comparable interface, then we say it's nature ordering. Okay. And the comparator, we say it's total ordering. So for this priority queue, so the order, it will be based on either using comparable or comparator. Okay, a comparator. So the priority, because you have priority, then you need to compare that. So the compare, so it allows you either using comparable or using comparator. Okay, so it depends on the constructor you use for the priority queue. Okay, we will see. But here it says priority queue does not allow null elements. So be careful, okay? And also it said if it is on nature ordering, it also does not allow insertion of non-comparable objects. Okay, so also we needed to be careful about this. So because it's queue, that so you can remove at the front, that and you can add at the back also, that and you can also retrieve the front item. So that's very general, okay. Okay, so that's regarding, let's see. And also in our example, you will also notice, okay, and if you recall previously, so because for all collection, because all the data structure, the concrete data structure, they implemented the collection, is it? And the collection basically is a sub-interface of iterable. And if you recall, iterable has that method called iterator. Is it? And iterator, the type is interface of iterator. And the interface of iterator, it has the next method to move to the next item. Is it? So then logically you will think, then if you have a priority queue, this is a priority queue, then you think of the item should be aligned by their priority. Is it? Then you say, okay, if I use the iterators next, I should get the item in sequence. Is it? But here, be careful, okay? Is that the iterator provided in the iterator method is not a guarantee to traverse elements of the priority queue in any order. Okay, so it's not guaranteed you will have the output as the item stored in that order. So that's not true. Okay, so if you do need to have order traversal, then you can consider to first do sorting. Okay, you convert the priority queue to array, and then you call the array sort method to sort it. Okay, so this we need to be careful, okay? But then you may ask, then how can I get them in order? That then if you want to get them in order, you just always, so whenever you do remove, the remove method will retrieve in order. Okay, so this is in order. This is in order. Okay, so in our example, we will also see that concept. So this is just some minor points we need to be careful. And then let's see. Okay, so for the priority queue constructor, previously, like we said, is it so it is based on nature ordering, or it's some other ordering. Is it? So we can, depends on if it is comparable or comparator. Is it? So if you just use the default one, don't specify, it's nature ordering. So it's the comparable one. Okay. And you can also pass in a existing collection, a specified collection. Is it? So this can be array list. It can be linked list. Is it? Can be a stack, some other data structure. Is it? So in specified collection, because all are all implement collection. So that's fine. Is it? And for the priority queue constructor, it can also allow comparator. So if a class, if a concrete class implements comparator interface, as a comparator interface, then you can pass it in. Okay, and then that means this priority will be based on the order that you specify with the comparator. Okay, and you can also specify the initial capacity. Okay, but a priority queue, like previously said, can dynamically grow. Okay, so that's regarding its constructors. It supports add and add, but here be careful. It's not always add to the back, because it depends on the order. Is it nature order or the order you specify? Okay, and the clear is remove all of that, and this contains just to check if kind of like search. Is it an iterator? We already know. Is it? And it also supports like the offer. So offer is also insert some item. Okay, and the pick is just retrieve but not remove. Okay, and the poll also remove. Okay, and you can also, oh, this is retrieve and remove. Is it? And remove just remove. Okay. Okay, so that's the general method that in priority queue. Okay, and next, let's take a look the example. And this example on our class website, it's called the priority queue. Okay, there are two files. We also have the book class. And we can take a quick look at the book class here. So this book class is that implements the comparable interface. And last class, we also saw our book class, but this time, this book Java file, it doesn't have the concrete class that implement the comparator interface. Okay, so this one only consider the comparable interface. Okay, then let's see the application. Okay, so first we create, so this is an array list of book. Okay, array list. So we have 3 books, and then we just add the book to our array list. Okay, and what this part does, this statement, so this is a call the array list clone. Okay, call the array list clone. So we create a clone of the above array list, but we will be able to see that basically this is not a deep clone. Okay, deep copy. This clone method itself from the list. It's not a deep copy one. And how we verify is we can get from this array list, is it, get the second item, then we reset it. Then we go to the first array list and get the item, we will see that item basically also modified. Okay, also modified. So we can take a look at this part. Let's comment out this part and run this program and take a look at the result. Then you will see. Because initially we have 101, 112, and 123. That. But did you see the book got changed to -100? Is it? So where we change? We change on the second one, the clone one. Is it? But then when you check the real one, it's changed. Is it? It's changed. And also then we can see this too. Is it? Yeah, it's changed. Is it? It's changed. And this one is removed. Is it? The second one is removed. But you will see the first one is not removed. The first one, that book is still on the list. Okay, so how all of this happens? So let's see. So basically over here in memory, you have B1, you have B2, and you have B3, is it? And over here, you have your list. So this is array list, is it? So array list, so it's kind of like array, you have the cell, is it? Then this will point to the book. Second one will point to the second book. Third one will point to the third book. That's how it works, is it? And then this list two, it call the list's clone, is it? So what it happens basically is, here it has a list two. So basically list two, in this case, it's just point to this list. So that's why the first one also point to B1, B2, and B3, is it? And you said this second one get one. So that's regarding this item, is it? And then you said, okay, I guess, so basically it's working on this item. So it's set its ID to -100, is it? And then you said, okay, I'm trying to see lists, but list also has the item pointed to this guy. That's why it's changed to -100. Is it negative to 100? Okay. And what then over here, this one said remove 0. Is it? So basically that just means, okay, the list 2, then it's start pointing here. So the first one, so its sub-0 will start here. But for list, here is its sub-0. Is it? It's sub-0, it's still. So that's why 101 is. So this 101. So that's why over here you still get 101. But for this second one, then you will get -100. Okay, that's what this shallow copy means here. Okay, so just be careful. And let's uncomment out. Let's comment out. Okay. And then let's just, so if you do want to have a deep copy, because if you just call clone, that's a shallow copy. So if you do want to have a deep copy over here, so we create a new one. Is it? Create a new one. And then you use the first one's iterator. We call it iterator. Then you do one by one. You do has next, and you call the next, is it, to get the item, and then you create a copy. And you add the copy to the second one. Then in this case, when you set, the first one won't be impacted. Okay, so this is a real deep copy one. Okay, deep copy one, and we can test it like this. Let's uncomment out. Comment out. Oh, then I also needed to uncomment all of this. Okay, then let's see the difference here. So this time, did you see it won't impact? So we set this one as -100, is it? And we try to output the first one. So the first one is still 112. 112. It's not impacted. Okay, so in this case, it's not impacted. And let's see why it's not impacted. So you have 3 books. So 101, this is B1. Then 112, this is B2. Then you have 123, is it? This is B3. That's the, and then we have that list. Okay, so this is 0, 1, 2, is it? Then this will point to the 101.1 to point to the third one, is it? When we use that iterator method, is it, then we have that next. So the list 2, it's called that new array list. So it's going to have its own memory location, is it? And then for each of it, it's called the clone from B1.clone, basically here. Is it? Because it's retrieved the first one. It's called this B1's clone. So this B1's clone, then what it does is it will create another 101. This is a clone. And then it will create 112. Then it will also create 123. Is it? Then in this case, the second, the third point to their own copy. Okay, so this is the first ones. Is it the 3s? And this is their own second sets, have their own copy. Is it? And also point to their own copy. Okay, so that's why we say this is a real deep copy. Okay, so if you want to, then you can use this. If you just call that list clone, that won't achieve this goal. So just be careful here, okay? Okay, so that's regarding this part. And then what next one, let's see, okay? The next one is regarding priority queue. Okay, priority queue. So let's see. Over here, we create another 2 book. Okay, so we have 5 book. Then for this variable, the type is priority queue. Okay, for this priority queue, okay, then let's see. Probably first, let's do this one. I will comment out this part, okay. We can come back later to take a look. Okay, then what we do here is we create a priority queue. And what's here? What is this? Is it, if you recall, the priority queue has different parameters for the constructor. So this constructor, it uses that comparator. Use the comparator. And the comparator, it has a method of compare. The compare method has two arguments. Two arguments. Is it? That's why over here we have two arguments. And the two arguments, the comparator is a functional interface. And the functional interface, that's the only one abstract method. Is it? So that's why what over here, all this is regarding that compare method you implement. Okay, so you compare based on what? You use books ID. Okay, we use books ID. So here, your priority arrangement is based on books ID. That's what you intend to do. Is it? What you are supposed to plug in is a concrete class which implements comparator interface. And because comparator interface is a functional interface, is it? So over here, we use lambda expression. We use functional programming. Okay, just directly specify, okay, the compare criteria we want to use is the ID. So it's much concise. So this is a concise way of programming. Is it? Okay, so we understand this part, is it? Then what we do here is we want to add the 5 books, is it, into this priority queue. Okay, and the order we add 112 first, 123. Is it 112, then 123, and then it's I don't remember, it's 101 something. Is it? So 3 other book. So if it is regular queue, then it should be in this order. Is it? But here, the order should be based on what? Book ID. Is it book ID? Then we will see when we do the remove, is it? We will see what the order is. Okay, so let's see the running result then. Did you see the running result? It's 101 first, then 112. Between these two, the same, then it's going to be based on the next. Is it then 123? Is it? So it's based on the ID. Okay, it's based on the ID. And based on the ID, and then let's see, go back. Okay, so this is you second. The first one is BBBCCC, is it? The second one is BBBZ and CCCZ, is it? So that's why when there is tie, then it's following first in, first in, first out. Yeah. So this adds next to it, as it's added after this first one. Is it same thing here? Is it? Okay, so that's regarding the priority queue that's initiated with you specified the criteria. Okay, and we can also comment out to this, and let's do this way. See, let's see, what does this mean? Okay. You can also create the priority queue. This is called the priority queues constructor. This is the initial capacity. Then what next? What are all of this? Previously we learned that this is called anonymous inner class. Is it? And you can clearly see here it does the comparator. Is it? And comparator has a method called compare. Is it? So you can also use anonymous inner class to initiate the comparator part. Okay, the previous way what we do is using lambda expression, because lambda is basically we don't need all of this. We just care about the implementation. Is it? We can cross out and just leave the arguments of the method there. It's a more concise way of programming. Okay. Okay, so you can also do implement in this way. Let's see the result. The result, then you can see it's the same. Is it? It's the same thing. Okay. Okay, so that's the second way. And then let's see the third way here. Oh, not this one. Let's take a look this way. Okay, we can remove this part. So this time, let's see. This time within the priority queue, if you take a look, it's called comparator dot comparing. So what is this? And then has another dot called then comparing. So basically, anyway, this is a method. Is it some method? Okay, and within this method, if you take a look, the get ID is also a method. Then comparing this get name is also a method. So basically, the comparator looks like it also has two other methods called comparing and then comparing. Is it? And both of them, they take method as parameter. They take method as a parameter. Okay, so you can also create some object with comparator like in this way. Okay, so let's take a look. Let's go back to take a look at the comparator. Okay, interface. Oh, I don't have comparator interface. Let's see. Okay, so let's get back to this comparator interface. So for this comparator interface, then over here, so the abstract method, it just has that compare method. Okay, compare method. And over here, And over here, let's take a look. We have this comparing method. Comparing method is what? It's a static method. Because it's a static method, that's why you just use the interface name, comparator dot. Then you call comparing. Is it what it needs in? It's just some method we already see. Is it? And is that it accepts a function. Is it? And that function will extract a comparable sort key from a type T. Okay, so anyway, so in our case, the ID, is it? And the name. Name is a string. So string, it has comparable interface implemented. ID is integer. Integer, it also has comparable interface. Is it? So both meet that definition here. Okay, definition here. So that's why you can also directly plug in. Okay, that's how. And what it returns, be careful, it's interesting. The return type is comparator. Okay, the return type is also comparator. And because the return type is comparator, if you recall, and we have that then comparing. Oh, it's here. Yes. Okay, so the comparing is from the default method. Okay, the default method, and it return comparator. Is it? And that's why over here we can call that then comparing. That then comparing, it has multiple versions of then comparing. Is it? You can plug in with comparator. You can also plug in with some method. Is it with some method? And over here, the method then over here, it's what it returns. It's lexicography order comparator. Okay, and same thing implements the comparable. Okay, the comparable. So that's what this comparing and then comparing comes from. It's quite useful. Okay, so let's just get used to it. Okay, so over here is you call default method. And here then comparing, same thing. Okay, it's default method. So it first use ID, then by name. That's what the order going to be, okay, for this priority queue. And then same thing, we add the 5 books for the priority queue, etc. And then over here, then we call the remove, etc. And we, let's see, because when we add, we didn't add following the order, but when we call remove, so let's see if it is following the order. So it shouldn't conflict. So over here is called using comparator. Okay, so let's see the output. Okay, the output, okay, it's here. Is it? So using comparator, that part, priority queue, is it? So it first using ID, and within ID, if it's the same, then it's based on the name. Is it the same thing? Okay, so it does work. Is it? Okay, so want to get it back to here. Okay, so that's regarding this part. So we understand. So today priority queue and more on comparator. Okay, and you can also see the advantage of using comparator. Then it's very flexible, is it, when you want the criteria for priority. Is it, then you can use in comparator. Okay, so that's why we have two different types for comparison. So just make sure, okay, this is quite useful. We can do comparable. We can also use comparator. And comparator is more flexible. And you don't need to bind it with your data structure. Is it, you can just specify when you want to create that data structure. Okay, so that's regarding the priority queue, okay? And what next we are going to see is over here, we have this variable, and anyway, it's an array list. Then we add all the books to the array list. And here we just do sort, okay? And for this sort, then we will be able to see it's just based on the nature order. So that's using the nature order. Is it nature order? Okay, for the collections sort method. Is it, we didn't define. Is it, so it's based on that comparable. Is it defined by book class? By book class, okay, so that's what here, how it works, is it? And you can also, for the sorting, collection sorting, you can also using comparator, okay? And then same thing, we can also borrow that comparing and then comparing, okay? Because anyway, what this part returns you is a comparator. Is it? That's why you can do chain the call another then comparing method. Okay, because you say, okay, I first want to use ID, and next I use name for comparison. Okay. Okay, and what next one try to show is over here, it's using reverse order. So collection also has a method called reverse order. Okay, for the book. Then here we output. So let's see. Yeah, so it does get reversed. Okay. And then next, let's see. So this is all regarding the collections. That, so for this collection, it's called a binary search. Find a specific book. Is it? And here then next you find the maximum and the minimum. Is it the largest and smallest within the collection? Is it the book, the array list? So that's all regarding the collections. So you can see it did give you the result. Okay. And then what next one try to show? This is a queue. Okay. So we already learned the queue. You can use linked list to initiate it. So then Oklahoma should be first. So using queue, then let's see the result. So using queue, then it's following the order. Is it following the order? Okay, then next, let's see. What next one here for this Q1, it's a priority queue. And for this priority queue here, it's anyway some object, and it uses object's length method to arrange. Okay, so it uses object's length for order. So basically for string, that's based on the string length. Is it? Then we add those 4 city names. Is it? Then definitely this should be 1, number 1. Is it? And between these 2, this should be 2, this should be 3, this should be 4. But this is the first coming in. Is it? Then we will see when we do remove who is the first, because this is the last added. But we will say it's going to be the first removed. So it does get to be put at the beginning, is it? And you can see, is it? This is the first added. Okay, first added. And then we see the next one, then the next one, and the next one. Okay, so that is okay, so it did based on the order, okay, on the priority order here, okay. So that's what it determines here. And here it use the string length. That's it. As string length. So this Indiana is 8 letters. This is also 8 letters. So between these 2, that's why that's based on their order to insert. That's it. Suppose if lexicography order, then G should be first. So Georgia should be ahead of Indiana, is it? But if we take a look at the result, you see Indiana, here. Indiana is ahead of Georgia, is it? Because both are the same length. And here our priority queue is only on the length, not on the letters order. Is it? This add next to Indiana. Is it? That's why it's after Indiana. Okay, so be careful here. Okay, so this is regarding the priority queue. Okay, priority queue. And then over here, we also show the priority queue. Then here we have the order added, is it? And then let's see the order we added. So we added this first 2, is it? And then we add Georgia, is it? So Georgia is ahead of Indiana. And when we output, you can see the order is not the priority queue's order. It's not arranged as that order. Okay, so here we need to be careful. Okay, the sequence in the queue is not always in the sorted order. Okay, but when we do the retrieving using that to remove, then we will get them in the sorted order. Okay, so be careful, very careful here. And the same thing with the iterator one, the order is also not in the order. It's not in the in its supposed order. Okay, so we need to be careful. But when we do the remove, is it? when we do the remove, that and it's going to be based on the order. Okay, so that's what it defines here. And also be careful, okay, for this priority queue, it's not arranged using the string length. It's based on the lexicography order, okay, the nature order. Okay, so that's regarding the priority queue. We didn't get time to